Good, everyone. Listen, I'm just here for maybe 1 minute, 2 minutes most. And I just wanted to talk for just a second about the announcement I made on Monday morning, the WD1 list of references. And I made the announcement because a number of students had questions on Piazza about the research sources, the research references for WD1. So I just wanted to make sure that everyone had enough information, and if there were confusing points, hopefully that I could clarify. And the announcement that I'm showing right here, there's nothing new in it. There's no new requirements. It's really just clarifying the assignment instruction. So, as you know, we're looking for 2 scholarly papers that will discuss responsiveness and usability in GIS or other interface design. They can be quite general. They don't need to be sort of specifically targeting the GIS that you're discussing in your state-of-the-art review. And one might focus on responsiveness, the other might focus on usability, or both might focus on both. And you'll use these to support your discussion in the state-of-the-art review, and the papers will also be useful for your proposal and your testing sections. And I think, as I've mentioned, certainly in a couple of the Piazza posts, if your team wants to include additional scholarly papers, just discuss this with your CI. We don't want to kind of hold you back with this, but we want it to be kind of a level playing field, so to speak. So just talk to your CI and work that out. And in addition to the scholarly papers, your team will need to cite all of the other sources that you've consulted. So certainly the 3 GIS for your state-of-the-art review. And I mentioned here, just sort of as an FYI, just for your information, that in the past it's been pretty kind of standard average that the WDI list would include maybe 10 to 15 sources. That's just simply based on what other teams have done in past years, but it's by no means a requirement. It's not fixed. So I was just providing that information just to give you a sense of what's kind of happened in the past. And one other thing I wanted to draw attention to, in the library resources, there is information on how to access Google Scholar. A number of students have had a bit of difficulty getting into Google Scholar. You don't need to use Google Scholar. You could use a different search engine, different database. But if you do want to use Google Scholar, if you go here, there's a nice short little 2-minute video that you can watch that Michelle Spence at the library put together. So if you want Google Scholar and you're having trouble getting in, there's a good place to go. And as well, sorry, I should have stayed there with the library resources. The link to the IEEE citation reference guide was broken, and that's been repaired now. So if you want to get some information on IEEE referencing, you can go through that link there. And as well, there's another way in. You can go through assignments into WD1, and you'll find there IEEE guidelines for 2018. Slightly different guidelines, but it's all IEEE. One that's prepared by the library. This is one that I inserted with the assignment. So anyways, hopefully, as I say, with the list of references, hopefully everybody's okay. I'm available on Piazza pretty much always. So if you're wanting to get any clarification, certainly let me know. And I'll turn over now to Vaughn. So if you do have questions, maybe fire those to me on Piazza or let me know. And hope all is going well for everyone. So thanks, Vaughn, and I'll give it over to you now.
Thanks, Ken. Can you hear me okay?
Yeah, I got you fine, Vaughn.
Okay, great. Let me make sure I've got a normal view here of myself. And okay, so today we're going to be talking about Milestone 2. A little bit at the start about how it links to WD1 and then into exactly what you have to do on the coding part. But before I go into that, I wanted to start off by, I know you're selecting courses in the next little while for next year. So I wanted to go through a roadmap of how this course connects to some other courses. So one of the things you've done so far in the course on pretty much every assignment, WD1, Milestone 1, is work in a team. So you're doing project management and learning how to work together as a team. So how does that fit into the curriculum at U of T? Well, you already learned about that in APS 111, 112. I'd say a difference in this course is APS 111, 112 tends to emphasize more waterfall, more specification heavy development processes. Whereas in this course, we emphasize more agile development practices where you implement a prototype, you get it working, you measure, you iterate, you improve. So that's the difference in this course. Building on what you learned in this course will be your capstone project in fourth year. So you'll do that in a team of typically 3 students. So there the project is more open-ended. You choose a project, you specify what you're going to do, and you implement it. So a lot more freedom there. APS 343 is about engineering leadership. So really focusing on the teamwork part. How do you create teams? How do you lead teams? Something that becomes very important as you go through your career. Actually, one of the most satisfying things that I've done in my career is learn how to lead teams, how to build organizations, and take pride in helping to mentor people to get to the next level. So this course is really about that. And there's the iLead Institute within U of T Engineering, which hosts a wide variety of project management and team management workshops. So you can click on this link, see what they're doing, and go join some of those opportunities, this semester and beyond. And then you're going to use these skills in your PEY and career and continue developing them, obviously. Okay, so that's kind of on the teamwork and project management side. You're obviously also learning how to develop software. And you've learned how to code programs as an individual, one person working on smaller programs in APS 105, and then you built on that in EC 244. And you learned about a bunch of the fundamental data structures in 244. So in 297, we're building on that. You're writing larger programs, you're working in a team, and we're bringing in more aspects of performance and algorithms. So choosing the right data structure, writing code that is performant, that is fast, and later in the course, we're going to get into some algorithms. We're trying to solve some more complex problems. Building on that, there are a lot of other software courses, but let me focus on 3. So in ECE 344, you will also do team coding and larger problems. You're going to write some challenging code to actually run the operating system like Linux that you are currently just using. EC 444, software engineering, again, is about how do you work in a team to write something larger. And on the algorithms and data structure side, ECE 345 goes deeper into the theory of what are efficient algorithms, what are efficient data structures, how do we prove they're efficient, how do we analyze their complexity. So these 2 courses are really on they go a lot into the craft of programming, particularly EC 444, so building on the team coding skills. And 345 is more on the theory of efficient algorithms, efficient data structures. And again, these are actually very important for most of you in both PEY and career, because writing efficient code, being able to develop large code bases in a team is very important. So these are likely to be very practical skills for you. Okay, so that's how some of what we're talking about fits into the larger scheme of educational offerings at U of T. Let's move on to Milestone 2. So an overview, I'm just going to give you an overview of what it's about first. So it's an interactive map visualization. So Milestone 1 was about building efficient APIs and data structures. Milestone 2 is about the end user experience. You want to see these these maps, interact with them, have a pleasant experience being able to see what's going on. The specification is somewhat open-ended. So we tell you you have to achieve certain base functionality, but we don't tell you exactly how. And then we say you should go beyond some of what we've asked for and come up with your own features. So the specification is a bit loose. You're going to fill in some of the details. We're going to teach you the basics of graphics. We've taught you about data structures already, and we've taught you how to use OSM data. So you're going to build on everything you learned in Milestone 1. But to get the best solutions to Milestone 2, you'll have to learn somewhat more by reading our documentation, looking through the code, trying things, and coming up with your own ideas. You don't have to do too much of that to get a basic solution, but if you want to get the best solutions, you can go beyond what we're going to teach you in lecture. So it's different than labs, or at least most labs. In labs, you generally apply what you've learned in lecture in a fairly direct way. And in this milestone, there is some of that, but there's also some design. Go beyond what you've been taught, and bring some of your own insights and ideas into it. Okay, so as we make things a little more open-ended, and this isn't completely open-ended, you kind of want to balance how hard you work on them. So our goal in this course, and really throughout U of T, is to kind of keep you in this zone. Okay, so this is a plot that I grabbed off the web. It's a very standard thing of how well do people perform, and perform in this case is learn. How much are you learning? So we'd like you to be learning a lot. We'd like you to be up here versus pressure. Okay, and the curve is bell-shaped. And this is true not just for learning, this is also in your career when you're working. You know, when you're talking about how much do you get done, the curve again is bell-shaped. If you have no pressure, if we just basically came in the first day and Dr. Tallman and I said, you know what, no matter what you do, every person is going to get 100% in this course, doesn't really matter, then you probably go, well, this was not a great learning experience. I'm not motivated to do anything. Okay, so we don't want you down there. But where we want you is you're doing some things you haven't done before. So that's called stretching. You're not 100% sure how to get everything done. That causes a certain amount of anxiety, but you learn a lot. So throughout my career, when I've actually been somewhat stressed, it usually means I'm doing something I haven't done before, and I'm actually learning a lot. And I actually find that comforting. But you don't want to get too stressed. So don't put too much pressure on yourself. There are open-ended aspects to this milestone. You do not need to do them perfectly. You shouldn't even try to do them perfectly because it's too much, right? And you will learn less. You will take away from your other courses. So if you find you're out there, back off from that. That's not what we're trying to do. We're not trying to make it too hard. And the optimal performance range is actually going to be a bit different for different people. So some people who are very comfortable with coding and they get the basic solution going pretty quickly, they may push themselves out here a little more, right? And other people may focus more on the more basic solutions, and that's fun. Okay, so often students will tell me that they were very stressed by some of the assignments in this course, like this milestone, and we're really not trying to do that. So I'm trying to take Dr. Tallman and I are trying to take some of the pressure off of you here. There obviously will be some difference in grades depending on what you do, but getting a reasonable, decent solution is going to get you a good mark. Okay, if you get an outstanding solution, then you're going to get a great mark. But if that's too stressful, just don't try for it and don't neglect your other courses. Okay. All right, so I won't belabor that anymore. If you are worried you're going too far, talk to your TA, talk to Dr. Tallman, talk to me. Okay, so what are you doing in Milestone 2 more specifically? So we've already talked about we have 2 layers of database interface. We have this OpenStreetMap data, and it's actually in 2 different files. And in Milestone 1, you made heavy use of the Streets Database API, which is the kind of more processed, more organized data, a little bit higher level, street segments, intersections, and so on. And in this milestone, you have to visualize pretty much everything that's in this layer, the streets database layer. So what I mean by pretty much everything: draw streets, draw the street names, tell me whether they're somehow graphically show me whether they're one way or not, show me where the points of interest are, show me the features like parks and buildings and so on. So display all of those things. And the details are laid out in the Milestone 2 handout, and I'll post a rubric shortly as well. It kind of makes that clear. So you've got to visualize all of that stuff. Okay, that's just what these features are. You can optionally choose to visualize some additional things that are only accessible through the Layer 1 API, which you haven't used yet. Okay, that's the OSM Database API. We posted a quick start guide on the course webpage about how to get going with this. As I said, the data is less structured, so we haven't processed this as much, but there are additional things you can pull out of it. And there's a lot of data there. So you can basically go to the OSM website and see, well, what is in all this data? And you can pull out things that are of interest to you. So one thing that's in there, for example, are subway stations. So you could pull out all the subway stations in a city and visualize them. And that could be a way to make your map stand out. So you don't have to do that. So you can basically not work with this API at all. But because we ask you to do some extra features, this is one possibility. Get some extra data from here and display it. Okay. In order to do this, I guess I already mentioned this. You're going to have to read our documentation on OpenStreetMap. We have a quick start guide on this, and then probably go to the OpenStreetMap webpage and read a bit more and experiment a bit. Okay, so the basic requirements for Milestone 2 are to visualize streets, features, so parks and buildings and so on, and points of interest. Points of interest are just spots with names like Tim Hortons, the Bay, etc. So all the stuff that is in the Layer 2 API. We want people to be able to interact with your map. So they should be able to click on an intersection to get some extra data. You don't necessarily have to draw intersections, but they should be able to click at least at a point and you figure out what intersection that corresponds to and tell them some things and probably highlight it. You should have a find button so that people can locate intersections by name. And you're going to find some of the functions you wrote in Milestone 1 are very useful for this. So I type in part of the name of a street or two streets or an intersection, find me that intersection and tell me some information about it. You need to be able to load any map without recompilation. So we provided maps of about 20 cities, and your TA will look at various cities. And you don't know in advance which ones. So make sure that without recompiling your program, you have some method by which you can load a different city. In Milestone 1, you wrote all of your code in, this actually should be main. In Milestone 1, you wrote all your code in libstreetmap. In this milestone, you're also going to have a little bit of code in the main directory. Okay, the code that's in the main directory gets turned into your end user executable, not the tests that are run by EC297 exercise. It's the extra code that starts your program up when the end user would want to run it. But most of your code will still go in libstreetmap. Okay, so libstreetmap is still where you're going to put most code. You want your graphics to be fast and interactive, and there's a lot of detail. We're asking you to draw a lot of different things, all the streets, all the parks, etc., names of things. That could get overwhelming for the user. So you're gonna have to figure out how do you make sure that your user, your TA, can see all this information somehow. You choose how. But at the same time, if they want the big picture of what does Cairo look like, they're not overwhelmed by all this data. So they have some way to, you either hide it automatically or they have some way to control it. Okay. So you want to be able to find all the detailed info somehow in some view, but the big picture, when they kind of look at the overall city, is still clear and not too cluttered. Okay. Okay, so how's this going to be graded? So this is all in the Milestone 2 handout. 2 out of the 15 marks are going to be assigned based on how you do things rather than what you did. So what does your code style look like? How do you manage your project? So very similar to the way we graded those items in Milestone 1. 5 out of 15 is basic features. So the Milestone handout has you should visualize the various things I just talked about. You should be able to click on intersections, click the mouse, find the closest intersection, give information on it, and so on. So that's laid out in the Milestone 2 handout. 5 marks for doing those and doing them well. Responsiveness, usability, and aesthetics is 4 out of 15. So how good does your map look? Is it easy to use so a person can figure out how to do things? Is it fast so they can as they're looking around, zooming in and out, it feels pretty natural. So a sample challenge in this would be to display street names well. So we want you not just to draw the streets, but also to label them. That's actually a non-trivial problem. You have to figure out what streets should you label at what zoom. If you label every street all the time, your display is going to look like a big mess. But at the same time, if I zoom way in and I can never figure out what a certain street is when I'm trying to really figure out what's going on in a certain neighborhood, that's a problem. So there's a fair amount of thinking about what are good ways to do this and how do I code those. And then 4 to 15 are extra features. So, and there are a bunch of ideas in the handout. I'll give a few here, but you're not limited to those. You can come up with your own ideas. So you could display some extra data from the layer 1 API, that OSM database API, and there's a quick start guide to get you going on that. So you could use that to show subways, for example. You could have more things that you can click on and interact with. So we say you have to be able to click and find intersections, but you could make other things selectable. You could get data from the web, and we've got a quick start guide for how to do that too. How do I go out to the web from a C++ program and start grabbing data? And you could use that to do all sorts of things. Maybe show traffic accidents, maybe show restaurant reviews, many different ideas. There, in the past, some teams have done things like actually have text to speech. So they actually have their map can speak to you. So there are a lot of different things you can try here. Don't try to do them all. So if you try to do a ton of complicated extra features, it's going to be too much. You're going to neglect your other courses. So only do that if you're feeling everything else is under good control. We don't expect you to do everything by any means on this list, right? We're just giving you some ideas. You decide how far you want to go on this. Don't hard code things. So we're going to test many maps, as I mentioned. You can run EC297 exercise. So that will actually load up a bunch of different maps and have you draw them. So it's a good way to check quickly with a lot of the cities that we've given you. Do I work well with them? And it'll also run Valgrind on your program. So you can check for memory leaks and so on. So that's a good idea to do. But your TA is going to run, and we will run the Valgrind checks on the code you submit. So you should check it in advance and make sure you don't have any memory faults. You also want to get rid of them because they make your program unstable, which would make development harder. Your TA, when he or she grades you, though, is going to be running your mapper program. That's the main executable, that starts in main.cpp. And so you want to make sure that you have that working as well. You want to check both these things. Okay. So any questions on that? I guess I see a bunch of different questions that are in. So the question, do all our extra features have to work with all cities? Or could some be specific to Toronto? Yeah, that's fine. So sometimes when you go out to the web, for example, you might find a web page that gives traffic information on Toronto, but not everywhere. That's fine. You would tell your TA, I've got an extra feature, but it only, I want to show it in Toronto. It only works in Toronto. That's totally fine. Make sure it doesn't crash in another city. So you don't want to basically go, yeah, my extra feature is a crash button in all other cities. Just make sure it doesn't do anything. Okay. And I think that was the main question there. So let me quickly switch to BNC and share from, I'm going to share the teaching team solution just to show you a concrete example of this. Okay, so hopefully you can all see that. Ken, I think you can see my screen, right?
Yes, I can, Vaughn.
Okay, so I'm going to run the teaching team solution for you right now. Okay, so it's calling load map. It's going to do Toronto by default. And yeah, just called load map and it called draw map. So now the map is up on the screen and that's Toronto. And let's see, let me just move this out of the way. Okay, so we can zoom in and out, right? So I'm just clicking on these zoom in and out buttons. I don't have a mouse hooked up, but you can also do this with the mouse. And as I zoom in, you can see, more stuff. So I can see buildings and eventually I can see some names. So in this solution, these names over here are points of interest, okay? That is hard to read, but it says Young Dental. So we're drawing points of interest just as little yellow squares and putting little labels on them. Let's see, I'm going to turn names. Right now I got names off. I'm going to turn names on. Okay, so this is actually also hard to read, but that's the name of a street. So it says Imperial Street. Okay, and I'm going to zoom out a bit so you can see what does this look like. Okay, the names disappeared. Names came back. What do you guys think of my usability and aesthetics? So on the plus side, I am drawing streets, I'm drawing parks, I'm drawing buildings. Labeling is ugly. I can barely see. Um, yeah, we didn't focus a whole lot on aesthetics. Okay. So the names are too small. So this is kind of hard to read. Um, our labeling of streets, frankly, is pretty crude. Like I'm just putting these little red markers on certain spots on streets, and they're pretty tiny. And then when I zoom out, they eventually all go away, and I can't see any names. Uh, so it's not great. I can turn on more detail. So I got a button here. I just turned on more detail so I can see more streets. Maybe that's better. Maybe that's worse. I'm not sure, but I would show that to my TA. And I can also, as I zoom way in, let's see, these points of interest showed up. So eventually I'm going to see them again. Okay, so all these yellow things are points of interest. This one says the UPS store, but again, the text really small, so it's hard to read. I can turn POIs off and those all disappear, right? I'm going to zoom out again. And if I want to, I have some controls, like I can turn off all of the parks and water and so on. Let me turn off the details. And I can show subways. Okay, so those are subway lines in Toronto. And to get that, we had to get more data from that lower level API. And if I zoom in enough, we actually start seeing the names of the subway lines or subway stations. Okay, so I see various comments. White of the street blends in the background. Hard on someone who's visually impaired. Get about 1 out of 4 in aesthetics. Yeah, so it's not great from an aesthetics point of view. So the teaching team and I, Dr. Tolman, Abbott, and I, and Samit, we lived our own advice, right? We had to decide how much stress can we handle, and we decided the aesthetics of this are good enough, right? So you will probably. So I'm not trying to claim this is like a fantastically aesthetically pleasing map, but it gives you some idea of what's going on. Um, it's harder than you think to make it look perfect, so we don't expect your solution to work perfectly either. Um, but you can try that. Okay. Uh, some of the other buttons I see people asking questions like salesmen and so on. Some of the other buttons I'm not going to show you till later in the course because you actually start running some algorithms, and we have buttons in there to visualize the algorithms. So we really focus on this as a reference solution we can use to help make tests, check out things in maps, and run our algorithms rather than making it really beautiful. But it is harder to make all of this stuff beautiful than you'd think because it's all got to work for multiple cities, got to be data driven. So maybe showing you that seems many people think that our reference solution is pretty ugly, so maybe that takes a certain amount of pressure off. Okay, that was running the mapper. Okay, I ran the command mapper to run that. That's where your TA will run. You should also check EC 297 exercise. So this is running the unit tests, and the unit tests for this assignment are mostly just to help you. Okay, so this one is currently going to draw Toronto. So it just opened up the same map as before, but if I click proceed, which I just did, it goes on to the next map. Okay, so this is Cairo. And if I zoom in, I'll see a little more detail about Cairo. Okay, so totally different city. All right, if I click proceed again, this next one is Beijing. Okay, and let's see if I can see the subways in Beijing. Well, lots of subways in Beijing. So just clicking proceed on this goes to the next map. Quick way to, I could check this with our mapper because I can tell our mapper what map to view, but this is a quick way to check all sorts of solutions. And let's see, that was Tehran, and this one's Iceland. Okay, and I'll stop going through them. There's about 15 of those or so. But at least once you should go through this. All right, so I just clicked X to end the program. Let me show you one unit test that you for sure should run. Oops. Okay, let's see if I have to. I think I might have to just Control C to completely kill this. Okay. So remember, I can run this list testers, and if you forget what are the options to any of the commands we wrote for this course, you can always just use -H. All right, so that tells me what are all the maps that'll be run. And I can run any of those that I like. So I'm going to run the tester Valgrind St. Helena. Okay. And that's a good one to run because we're running Valgrind on your code. And you want to make sure your code doesn't have any memory faults, because that is the one unit test that we are going to check, and we'll deduct not much, but we'll deduct up to 1 mark if you have Valgrind errors. So you don't want that to happen, so just check. And more importantly, we're doing that as a favor to you, to help you. If you have memory errors in your program, it will be unstable, so you want to find those right away. Okay, so St. Helena doesn't have much in it, so that's that test. And I passed. Okay, so we didn't have any memory faults in it. And let's see. So I think I can stop with that. I can stop sharing from that screen. I'll go back to this one. Okay. So any questions on any of that? I see somebody saying England is my city. London actually looks pretty cool. Certain cities, London, Tokyo, Beijing, and New York actually look pretty cool. So it's good to bring them up. Okay. I see someone asking, could an additional feature be adding more than just the 20 maps we were initially getting? That's kind of hard because you need to use our tools to generate them. So maybe talk to me offline about that one. The zoom, you're going to see as we go through. So it's a question of, is the zoom natural? The zooming functions are actually really easy. Because of the graphics library that we've written for you, you're going to get zooming basically for free. Okay? And I'm going to show that as we get further into the lecture. Okay, so let's talk about extra features. So we could change our color scheme. So Dr. Tallman and I, we've been brainstorming this for weeks, and we came up with this fantastic idea. We're going to change the color scheme. Okay, we're going to have a pinkify button. So here's our usual map, and whenever you click the pinkify button, it gets more pink. And you can click it many times, and it gets more and more pink. Okay, so what do you think of our extra feature? Okay. Okay, so I see various things from I love it to useless. Ken, what do you think? You were maybe a little more skeptical about this feature than me. How do you feel about it?
Well, I am still a little bit skeptical. I agree with many of the students. Like, what is it doing? What is it showing me other than just pink? Is there a purpose?
So it's not great in my opinion. So let's see if I can. I got to try to get my view back to a normal one. All right. Well, maybe not. Okay. So yeah, this isn't a great extra feature. So you'd get something for this, but your TA knows this isn't very hard. Also doesn't seem to have much point to it. So it's not a great extra feature. Difficulty matters. We can tell whether something's easier or hard to do. Okay, so you could do, one difficult feature. You could do a few easier ones. It's up to you. And your TA will assess essentially the quality of what you did and also the ambition. But that said, don't go crazy with this because you don't want to spend all your time on this course either. So you have to kind of balance things. Okay, so how does this relate to WD1? So Dr. Tallman talked about WD1, and it is linked to Milestone 2. So you're starting a new project, and what you want to do when you start a new project is make a proposal. Okay, and you should begin that by surveying the landscape. Do some background research. In this case, figure out how do others make GISs that are responsive, so fast, like they feel fast, and usable but detailed, because that's the challenge we've given you in Milestone 2. Show me lots of data, but don't overwhelm me. So there's a usability challenge implicit in that. So you should go look at how do other people attack this? What makes user interfaces intuitive? How fast does a user interface have to be before people feel good about it? It feels responsive, feels natural. And as Dr. Tallman said, go use credible research for that. Look at good sources, come up with some ideas. Then you want to make a plan. So what are you going to do? So what ideas have you found from the background research that seem really good and you want to use them? And what are other areas where you want to be different? Tell us that. And then how are you going to measure success? So that's an important thing in any proposal. So what are the goals? What are you trying to do? How are you going to test them? And again, the background research hopefully can give you some ideas here. And this is part of your WD1. you never want to skip this step of surveying the landscape. And that sounds obvious, but people do it all the time. So I've supervised many grad students. I've been on many different committees evaluating graduate students' final theses. So when you go to grad school, you spend several years, 2 years for a master's and 4 or 5 for a PhD, working on research, and you ultimately write a thesis. And part of that is you have to survey the landscape in that thesis. You have to say, what have other people done before, and how is what you're doing different? How is it better? And some people do this at the end. They just had some ideas, they went off and they implemented them. And then after 4 or 5 years of a PhD, they go out and do a more thorough literature search. And they sometimes find, oh, there's actually a better way to do this that people know about. I wish I knew that 4 years ago. So you always want to start this at the beginning. Survey the landscape, make sure you're not reinventing the wheel. Okay, so let's do I'm going to try to do a quick breakout room here. And I want you to discuss, how are you going to make the test part of WD1 in this proposal? How can you concretely set goals or tests for usability and responsiveness, which sound like kind of fuzzy ideas? So I'm going to do a short breakout room, and we'll come back in just a few minutes. Let me make maybe 30 breakout rooms. Okay, and so go and discuss that idea, and then we'll come back and chat about what are some of the ideas you came up with. Okay, so welcome back, everybody. So what ideas did you come up with? How could we measure these somewhat seemingly vague things? Okay, surveys. Okay, so is that for both? Whoops. For both usability and responsiveness? Okay, so surveys. So you get asked to this users, find people, do surveys of people using your program, and not just the team. Okay, it sounds obvious, but programmers are actually very bad at evaluating how easy to use a program they created is. As I told you, I worked for years, one of the architects of Quartus, which you used in 241. We would ask people what they thought, and they didn't think the same way the developers did. We knew what we were thinking when we wrote the program. People often they did not use it the way we thought. Okay, so test one-on-one. Yeah, so one-on-one test. What we'd actually do with Quartus, we'd actually videotape people. So we'd put people in a room and have them use the program, and we'd videotape what they did. So we could actually see, are they frustrated? Did they couldn't find things, etc. So you could sit there with a person, or you could even videotape them. Okay, have a reference map to test responsiveness. Okay, so I think you're saying measure on a reference, and that makes sense. So how are you going to measure this? Okay, so I see like which one loads faster and by how much. So you can time it. So should we time it with a stopwatch? What should we do? Okay, so for responsiveness, you can actually be pretty concrete. You can time it. Okay, so you could time it with a stopwatch. Do you think you can do any better than that? Okay. Write a program to time it. Responsiveness isn't just about speed. A lot of responsiveness is about how fast you respond. So I go and survey the literature and come up with your case of what you think responsiveness means. But yeah, often it is very tied to how quickly does the program get back to me. Okay, so can I do with a stopwatch? I see someone saying use timestamps. Okay, so timestamps basically means, can I measure in the program? And yeah, there are ways in a program to get to get much more accurate times than you can for much smaller time scales than you can get by just measuring it with a stopwatch. So that's a better way to time things, right? You can measure things before and after a function. That's exactly right. You can print to a log file. So there are ways to get good times out of a program. Um, Another idea for usability that's often used is time tasks. So you can actually time things for usability as well, where you can do things like see how long does it take someone to complete a task when they've never used the program before. Okay, so it's probably going to take a while. It can take them a while to actually go and find all the right buttons and so on. And again, we would do this with Quartus. You ask somebody to do some particular task that's related to chip design, and they don't know Quartus. How long does it take them to figure it out? So it might be several minutes. It might be forever. It's probably not going to be 2 seconds. 2 seconds would be great. So that's like a novice. You can also time the tasks for an expert. A person who's actually done this, used this program quite a bit, can they do things quickly? Or is it just impossible? It actually just turns out that you've hidden things so much and required so much typing that even an expert, it takes a long time to do basic tasks, right? And I see someone say you could see how many mouse clicks it takes. So yeah, you could do that, and that's a good metric. Time in a way actually captures all of this, because if you had to click the mouse a lot, then you're probably slower. So um, so those are some ideas. Okay, so some of those related to timing, particularly responsiveness. So how do we time functions? So I'm just going to show you some code that you can use, and this can be useful in Milestone too. So in C++, the main time utilities are in a header file called chrono. So it's part of the standard library, so you include it. And you're going to see in next lecture that the main drawing function, well, that redraws the bulk of your map visualization. You can call it anything you want, but in our examples, we call it draw main canvas. Oops, sorry about that. So this is like the top level function that gets called to do a redraw. So it's really important for responsiveness that this be fast. So I want to time this function. So how do I do this with this chrono header file? Um, Basically, I get a start time, okay? And I can call functions in chrono, and I'm calling a function called now. So it just returns an object that records the current time. This draw main canvas could get really long, really fast. So I'm going to use a lot of helper functions. I want to get good code style. So I've got a helper function called draw my stuff. Maybe I got a bunch of helper functions. This could do a lot of work. Once it's done, I've redrawn the screen. I can basically get another time. So I just call now again and say, tell me the time now. And I can subtract those two times. And then I have this funny bit of code, which is actually converting that object into an actual time in seconds that I can print. So that's what all this line is doing. Subtract the two times, convert it to time in seconds that I can print out, and then just print it out. And this particular time measurement that I've done is called wall clock time. It corresponds to what you'd measure on a stopwatch. It's just like the real time that's happened in the universe between these two events, which is what an end user cares about. They don't care whether the operating system was taking time, whether your program was taking time. They just want to know how long did they have to wait. So this is a good way that you could time that function. And now you can see if it meets some metrics that you might have found are important. You can also use it to tune the function. You can try changing things and see if it gets faster or slower to try and improve it. Okay. Any questions on that? So that's it for kind of the link to WD1 and how do you measure time in C++. Okay, so I got a couple minutes left, so I'm going to give you a quick intro to graphics. We're not going to get too far in this. We'll talk about it more tomorrow. Okay, so to draw things on the screen, you need to do one of two things. So you could do what you did in ECU 241. Well, let me ask this first. In ECU 241, I assume you use the VGA display. Is that right? Usually most years students do that. So did you use the VGA display? Yeah. So the VGA display, you're basically writing directly into memory that is being read by the graphics hardware and drawn on the screen. So you're writing straight into a memory that is basically the screen. Okay. So you can do that, but there are some drawbacks to doing it, particularly in a larger program. So first, it's low level. So it's a lot of work to do this drawing. You're drawing an entire city. So that's probably a lot more complicated than what you were drawing in ECU 241. So it could be a lot of work to do this if you're directly writing pixels into a screen buffer like you did in 241. It's also different on every platform. So if you do that, You're going to do it for Windows. You're going to do it for Linux. You're going to do it if you want to print on a printer. And in fact, you may do it for every single version of Windows and for many different computers running Windows. So it can be a lot of work to keep this going. And then the last problem is in EC241, you were running right on the hardware. There was no software between you and the screen. On Linux or Windows, there is an operating system between you and the screen. The operating system is there to enforce security and sharing. It will not let you write directly to the screen. So even if you tried to do this, your program will be killed with a segmentation fault. It's not allowed. Okay? So can't do that. So what are we going to do instead? So we're going to use a cross-platform graphics API. So application programming interface, just a bunch of function calls you can make. So it's higher level with easier to understand functions so you can get going faster, get things done quicker. It can target different hardware. So you call the same functions all the time and they just do different things on different hardware. So you're insulated from that. And a graphics API includes some code that's called device driver code. That is special code that the operating system allows to access the hardware. Okay, so it needs special permissions, but it's given that by the operating system. So this code can get at the hardware, can get at the screen. So what are you going to do in this course? So you're going to write, some program. Okay, it'll be actually called Mapper for you, not my program, but this is the program you write. It is going to talk to this graphics API. And in this course, we give you an easy to use graphics API called EZGL, which we wrote for this course and not some other purposes. It's used for some other things too. So it's pretty easy to use, handles a lot of the setup and tear down and makes things easier for you. That graphics is often layered, and this is a layer. So that EZGL API is layered on top of a lower level API, so a more detailed, harder to use, but more powerful API called GTK. GTK is used to develop a lot of the programs on Linux. So a bunch of the programs that you're actually running in the labs that are running your user interface are also written in GTK. You don't ever have to write any code directly in GTK if you don't want to. So EZGL will call GTK for you, and you can just, after this slide is over, you can ignore that it's on top of GTK completely. But if you want to, you can make direct calls to GTK to get extra user interface elements. We give you all the source code for EZGL, so you don't have to read the source code. You can just read 2 header files that tell you how to call our functions, and that's all you have to do. But if you say, I don't like the look of certain things, or I want to go in and add some enhancements, make some new user interface elements, you can change anything you want. Okay? And yeah, are you allowed to use EZGL elsewhere? Yes, you are. And in fact, it is used actually for other courses and for some open source projects as well. And yeah, you're allowed to use it elsewhere if you want. Okay, so and this GTK library is what gives us platform independence. So it can target Windows, Linux, and printers. So it gives you all of those things, and you don't have to worry about it. You just make the same call all the time, and all these other things just work. Okay, and I'll stop on this slide, but just how do you get going? You type EC297 init2. It'll add the EZGL source code to your Git repo. Read the basic application.cpp file in the EZGL example. Okay, so there's an EZGL quick start guide that describes how to use this graphics library. And the best documentation, frankly, is this example program. So this is one CPP file that shows you how to start up a window, how do I draw on it, how do I do various things. It's heavily commented. So if you read that, you have a pretty good idea of how to actually use this. The 2 header files that you need to include in any CPP file that you want to draw anything are these. EZGL application and EZGL graphics.hpp. So same as .h. Some programmers like to use .hpp instead of h, but these are .h files. So include those in any file where you want to make graphics calls. And we'll talk more about, okay, well, what's inside this and how does it work tomorrow? But this is what you need to do to get going. For those who haven't gone to the tutorial yet, we're also this week and next week doing a walkthrough of how do I actually visualize a map using EZGL? We're kind of going through in detail, how do I get it on the screen? How do I start drawing some basic things? So if you haven't checked out the video or gone to the tutorial yet this week, you should do that. And you should go again next week, because that'll also help you, show you very concretely how do I get going in visualizing a map with a graphics interface like this? Okay. That's it for today. I'll stay on the line in case there are any questions, and I'll stop recording.